4.1 talks about antiderivatives. What that would mean, you are reversing what you did to a function to get a derivative. To get there, we're going to first find the derivative of these functions and see how this works. When you take a derivative, you bring the power down, subtract 1 from the power. That's the shortcut. If I take a derivative of x squared plus 30, well, that's 2x plus 0, that's 2x. If I had f of x equal x squared minus 100, then a derivative of that will be 2x as well. Actually, if f of x equal x squared plus any constant, when I take a derivative, I bring the power down, subtract 1 from the power. So the deal was, if you take a derivative of x to the n, where n is a real number, you bring the power down, subtract 1 from the power. That was the deal. Now we are reversing those steps. So given 2x, we want to figure out what did you take a derivative of to get that 2x. So if f of x equal x to the n, where n is a real number, then the antiderivative, we represent that by f of x in the beginning. To reverse, bring in the power down and subtracting 1 from the power. To reverse that, you add 1 to the power and you divide by that new power, as long as n doesn't equal a negative 1. And if I take a derivative of this, I should get what I started with. The issue comes up with, we do not know when we reverse a derivative, whether there was a 30, negative 100, or any constant. So we always assume there was a constant, and if it's 0, we say, well, let the constant be 0 then. Find the antiderivative of the following functions. So I'm trying to figure out, what do you take a derivative of to get 3x? Well, according to this rule, the 3 I'm going to ignore. The variable x, I'm going to add 1 to the power and divide by that. So that would be what you would take a derivative of to get 3x. And you could check quickly if you like. And of course, we're going to have to add a c because we're not sure if there is a number. If there's a 0, then we say c is 0. And if you take a derivative of this, don't you bring the power down? The 2's cancel out and you're left with 3x. What if I have multiple terms? Well, that's no big deal. It's just like we took a derivative of each, we will take an antiderivative of each. As long as it's a power function, add 1 to the power, divide by that. Add 1 to the power, divide by that. Add 1 to the power, divide by that. And what do you take a derivative of to get 1? Well, you could think of 1 as x to the 0 if you wish. So add 1 to the power, divide by that, or simply, what do you take a derivative of to get 1x? And don't forget, you need to add the c. You add a c every time you find the antiderivative, which is something we're going to be doing now. How about if I took a derivative of a function and got x squared minus 5x to the 5th? Then the function must have been add 1 to the power, divide by that, leave the 5 out, add 1 to the power, divide by that, plus c. So it's fairly simple. How about x raised to the 1.3? Well, you must have had x, add 1 to 1.3, that's 2.3, divide by that. So whatever the power is, as long as it is a real number other than 0, add 1 to the power, divide by that. Similarly, if I get to this problem, well, I'm going to write f of x as a power function. That's x to the 1/2 minus x to the 1/3. So f of x must have been add 1 to the power, divide by that. minus, add 1 to the power, 1 plus 1/3 is 4/3, divide by that. But dividing by a fraction is the same as multiplying by the reciprocal. Dividing by a fraction is the same as dividing by the reciprocal. There it is. Okay, that didn't register. Let's do it again. And if I go for E, add 1 to the power, divide by that, add 1 to the power, divide by that. So the antiderivative will be x to the negative 2 over 2 plus x to the negative 1. The rule of thumb is if you start the problem with negative powers, you could leave your answer with negative powers. If you start the problem with positive powers, you should leave your answer with positive powers. But that's something we're not going to disagree on, me and you. However you do it, I'll accept it. Now, before I start this problem, I notice this has a fraction, so I'm going to rewrite this. I'm not doing an antiderivative yet. I'm going to say that's x to the negative 3. And when I say now what's the antiderivative, add 1 to the power, divide by that. 2, add 1 to the power, divide by that. This has been happening. And that must have been 6x plus c. So again, this is accepted on a test. But if this problem was in the back of the book, since they had a positive power, they will simplify and write it as a positive power. Last problem, again, before I start, I'll rewrite it. And that's x to the 1/2. So capital F of x is add 1 to the power, divide by the new power, 5/3. Add 1 to the power, divide by the new power, add 1 to the power. Dividing by 3/2 is multiplying by 2/3. That's a fine answer for a test. 3 over 2x minus 5 over 2 times 3, that is 6x squared. And that would be the answer. And that's pretty much it for this section.